Well, hello, everybody. We're on to the second to last session for today, and this one is on instructional applications of community as a living lab on and off campus. And a number of years ago, there was a publication and a task force set up that they developed a guide for doing or you're on campus as a community or living lab. And that document we have in the resource area, so you can look at that. One of the things that I've kind of thought about it over the years, and it's not necessarily true, but the campus as a living lab concept, I've always thought, well, you're going to just go within your building and use your building as a way to teach your students. But it's more than just that. And we're going to cover some of that and give some ideas and some examples of it. We have two instructors with us. Justin Haynes from Georgia Piedmont. Many people are familiar with him. And we also have Patricia Thompson or Trish Thompson from Allegheny County. And so they will be speaking about their experience with it. And there are different types of looks at how you can use this. And so there's many different ways you can go about bringing in other than just your lab or your classroom equipment into teaching your students. And that's one of the things that I've done over the years. Go on to the next slide. So what you can do with this is you can use it to help other entities such as your campus operations or some other entity. I've done it a number of times for other community organizations, manufacturers, warehouses, a museum. So it's a great way to get others involved with this. You can also involve other academic departments, solicit off-campus opportunities, and look for ways within other programs within your college to bring them in and get this to be more of an inclusive from a cross trades perspective. You get to have people interacting, which you're going to be doing in the field anyway, typically. Before I go into these next slides, I'm just going to have Trish and Justin introduce themselves. Justin, you want to give a little bit of background of where you're coming from and your new role as director or sort of new role?
Absolutely. Thank you, Ted. Hello, everybody. I'm Justin Haynes, director for building automation systems here at Georgia Technical College. And I've been here for about 2.5 years. And before that, I actually was a student here. So, I'm well rooted here. And also, I had a lot to do with building a lot of the living lab experience here. So my students can get their information straight from the source, I like to say. So yes, I've had a lot of experience with the Living Lab, and can't wait to tell y'all about it.
Trish, you want to give a little background on yourself?
Sure. Hi, I'm Trish Thompson. I am currently associate professor at the Community College of Allegheny County, which is located in Pittsburgh, Pennsylvania. I've been with the college for 10 years. I've had various different roles. I started in mechatronics, moved into engineering, and then was asked to develop the BAS program here at the college. So it's a pretty new program, but I have some information on how we're trying to promote the program with our lab.
Just a little bit of how we're going to conduct this session. It's meant to be more an interactive session. So as either Justin or Trish are speaking, feel free to unmute yourself and ask a question or raise your hand, however you want to do that. We want your ideas as well as for our ideas come out to you. So we're looking for other ways to do what we do, and we hope that you can bring in what you've done so we can learn from you also. So I'm going to go through a little bit about the Living Lab guide, and they have 8 different elements in here. Engage the correct campus participants. That's a very difficult one to do. As we go through, I'll explain some of my difficulties with that. Identify key collegiate programs, if you're going to work with other programs within your college. Build credibility through engagement and data. So that basically saying, as you do things on the campus or for an entity, the information you collect and are able to present in a cohesive manner really helps to get their buy-in that they want to work with you, not just on this project, but other projects. Get it integrated into the curriculum. And this is one where it's a more difficult thing to do. And we'll talk a little bit more about that as we go through this. Expand beyond individual programs of study. Build partnerships with industry. And if you're going out to the community and working with industry partners, that's a great way to do just that. And that way they have an opportunity to see how your students perform and hopefully interested in hiring them. Engage support beyond the campus and open your labs to the community. I've done some of these or all these things to some extent, some more than others. So something to keep in mind as you look at this and as we go through it. I just want to throw out some pros and cons for this. Going outside the classroom has tremendous positive impact on learning and student experiences. There's nothing like a student being able to see, feel, and touch the actual equipment that they're going to be working with. In your lab, you have some of that, I'm sure, but it's different when you look at the equipment that's actually currently running in the buildings. And it's also different when it's outside of your campus. You get to see all these different other pieces of equipment. And a chiller on campus might look a lot different than a chiller at a museum or some type of manufacturing plant. There's all different shapes and forms that you can't necessarily have in your facility or in your labs that they can get exposed to. It helps others have a real impact on the students. So seeing other people, what they do can really spur a student on to learn a lot more. It can lead to jobs. The entity where the work is conducted benefits from the expertise of the class and instructors, you as an instructor. And entities do this as part of their mission to impact communities. So we worked with a children's museum locally here, and that was one of their missions, is to work and help educate and coordinate with the community on different types of projects. The negative parts of it, or cons, you have to be able to find these sites, and you have to have a good rapport with people on that site to make sure it's something that your students can actually learn from and work with. You also have to manage their expectations, because that can really kind of get out of hand. They have to realize that these are people who are just learning what to expect when they're going to work into or come into an entry-level job, so that those expectations have to be tampered down quite a bit. Also professionalism. You got to make sure that they realize that they're interfacing with potential clients and or employers, and they need to be professional in their approach. These projects are one-off projects typically, and as a result, it requires a lot more coordination on your part as an instructor and a lot more upfront work, and also during the whole course of the project. So it can take a lot of your time and effort that you may not be used to doing. So with that, Justin, I'm going to pass it over to you and let you talk about your experiences. And before I do that, anybody have any thoughts or comments about what I just presented? If not, Justin, go ahead.
All right. So a couple pictures down below. I wish I actually edited, because there's some wording there that's important. But I can tell you everything about these pictures here to start off. These are pictures of my lab, the living lab that we have here on campus. And so I want to start off on the right.
Sorry about that. I was going to try to move that off of the screen for you,
Okay.
but go ahead.
Oh, yeah. Let's go to the first slide.
There we go.
Okay. So the picture on the right there, you see our control center. We call it our control center because that is a room that is in the middle of our building C, and it has 24 rooms in it. So we are able to monitor the temperature and the motion of every room in that building. And that is not the only thing we are able to do. That is just the most wires that are accounted for on the input side of our EasyIO and also Metasys controllers. So we not only check temperature, we not only check motion sensor, we check humidity in the bathrooms, and we check CO2 for safety, and we check we have a couple of rooftop units in the next room over, which is our HVAC lab, and we are able to actually coordinate with our fellow commercial HVAC students. So basically, we're able to collab, as Ted was kind of explaining earlier, with other trades. We can also collab with trades such as plumbing. So we could check temperatures, for the buildings, the pipes going into the bathroom, things like that. We could check those and have, if anything's going wrong, let the plumber go fix something. We could set up set up issues, but then again, that might be on that con list that Ted actually just put up, because you are actually working on the building that you are studying in. So that just lets you know what kind of things you may or may not want to do, or some kind of things you may want to stay away from. But for the most part, we use our living lab for monitoring, right? So currently it's all inputs. We aren't connected to the HVAC directly in terms of the fans and heating, but we are connected in terms of sensors. So we could sense the outside air temperature, the return and supply for a couple of units. So that's how we're using our living lab in terms of how my students are able to manipulate things around the building. So with that being said, we've also recently I've reached out to a church that has started a STEM program across the street from where we are now, and I'm planning to bring them in so that their students can go ahead and get the same kind of experience that my students have. Of course, it's not going to be as extensive because my students are here year round, but have, little workshops here and there. So, the community's mind can be expanded as to what's actually going on and what kind of treasures we have here in this living lab. So I want to get back to exactly what kind of material, what we're using in our panels here in the control center. So we have EasyIO, which some of you know is open protocol. And then we have Metasys, which is closed protocol. And we like to just use that as to show the difference in different kind of controllers. And you want to just kind of have a variety whenever you're using your living lab. And the main thing that I like my students to focus on is how to read the manual in order to change from one controller to the other, to see, and that way they'll notice similarities and differences between different companies. So anyway, let me go ahead and kind of stick to the script here. So yeah, we have the Living Lab experience at GPT's BAS program, innovative and hands-on learning environment. Before we even started the Living Lab, as you can see, the lab I'm in now, we just kind of had devices kind of dispersed out, and then you could kind of plug and play with them. But it didn't really, it wasn't based off of real life situations. Like you weren't able to see trends of, let's say, okay, well, this door's been open. I mean, this room's been occupied for so and so hours, and the light's been on for, however long. Things of that nature. The temperature here has been rising, and then you find out that a window's been open in a room. So anyway, that's kind of the way that we've been using our control center. So so far I gave you a pretty much the living lab in a nutshell, but are there any questions so far? I'm seeing some people I've seen in previous events. It's good to see you all. Are there any other questions about these pictures you see here, or anything about the lab itself that we have before we move on?
Hey, Justin, this is Larry.
Hey, Larry.
Um, I know you also have a commercial refrigeration lab there at the college, right? So again, are you also tied into that?
Yes, thank you, Larry. Yes, I don't know how I forgot that because it's right next door to the picture on the right. So that commercial lab, it actually has an energy management system. As you know, in a commercial refrigeration lab, you have all these different ice machines and cooling and cooling walk-in coolers and freezers, things like that. So we're able to check the energy usage for that whole lab, and we're able to check the temperatures of the freezer and the cooler. And one of the another cool thing about that lab is it's actually a taller ceiling than any other room in our building. Therefore, as many of you know, you would need to stack up multiple temperature sensors. For that room, we have 4 stacked up so that we can average out the temperature. And that average goes back as an input to our control center here into our medicines, and then we're able to just monitor the temperature. Of course, there's no output just yet, but yeah, we're able to monitor it and say, okay, well, maybe we need to call somebody to turn up the heat or turn down or something like that. Um, but anyway, those are the main things we're able to monitor. And outside air temperature is something that is connected to the outside of that room, that particular room. So those are the main things we're able to check in that room. Thanks, Larry.
Justin,
Yes.
this is Rob McNabb from North Shore Technical Community College. Do you have plans to add analog and discrete outputs to that curriculum or exercises involving those?
Thanks, Rob. It's good to see you again. So yes, actually, I've been talking with the chief security, and often when they are closing up shop, when they're closing up all 4 of our buildings, they find that many instructors haven't turned off the lights. So they find it a hassle to have to go through and turn off the lights. So with that being said, they asked us, the chief has asked me to go ahead and find a way to turn off the lights, after some time of there being nobody in the room. Of course, that deals with occupancy and motion sensors and things of that nature. So that is a plan and a project that I plan to put into play for my curriculum. And yeah, that is one thing. As for HVAC, not necessarily just yet, but we do have offset rooftop units that aren't necessarily going into rooms that aren't really providing air for rooms, and we can manipulate those. However, those aren't necessarily dealing with the actual building itself. But we are going to start with the lights for energy conservation. Thanks, Rob.
Well, thanks, Justin. Outstanding.
Yes, sir. All right. Are there any more questions about this first slide and the first presentation? All right.
Quick
Oh, yeah.
question for you, Justin.
Yes.
So, with that lighting project, are you being asked to do that as the instructor, or are you planning to make that a student-facing project? And if you are there any hurdles you anticipate?
Well, in terms of hurdles, I would just say typically when you're dealing with, building maintenance people or people who have certain contracts to maintain the building, then that's when you may come into having to be on their schedule, or maybe they don't want you dealing with certain things. Now, I haven't run into issues where they said no and don't want you to do anything, but those are possible hurdles. However, Let's see. Oh, also, you may also find, especially for those who've been in building automation in the field, you can find that the building maintenance guys may not necessarily have up-to-date, let's say, schematic diagrams, wiring diagrams, things of that nature. So, that's always in the mix to kind of throw you off when you're starting a project. But yes, that is a project we're going to start soon, and I'll actually keep you all updated with how that's going.
Awesome. Thank you.
You're welcome.
Next slide.
Yes, next slide, please. All right, so I talked a little bit about the lab features. So we have real-time data collection and monitoring. That's our main focus. Because as you know, if you want to go into consulting in the building automation, going to any building, you want to be able to read the trends and find the schedules. Those are the main two things. That way you could kind of dissect the situation much easier. So on the right, I have two students who have actually installed the Metasys for me. We had Siemens controllers in there first. We struck a deal with Metasys and Johnson Control, and I had the students unwire the Siemens controllers and then plug in some Metasys controllers. And then I'm going to have students do that every year as one of their final projects so that they can have a full understanding of how to read schematics and how to properly wire things, properly label, wire management, all the physical aspects of what really makes building automation tick. So also, they already learned conduit bending, but in this living lab, they can actually mount conduit on the wall, run actual wire that will be used and tested through the conduit, as you see there above their helmets. Things of that nature will be all implemented into this living lab experience. And so on the left there, now this isn't necessarily part of the living lab, but there are aspects of this lab that I'm in now that are attached to it, such as the energy management for every building. There's a current transducer in the water closet, basically in the electrical closet, that can basically monitor all the energy usage on the whole campus here at Clarkston campus. And that goes back to our control center. And that involves all the equipment you see there in my room here. And students, they would bunch up and read data and things of that nature. And eventually I want to tie in the lab that we have here, which is actually the Zigo from Siemens. It's ran by Zico here with the living lab in another building, in the C building. So anyway, that all sounds a little more complicated, but basically this lets you know what kind of opportunities this whole living lab experience has for us in order to integrate. So integrating building management systems is key. So we're going to use a lot of backnet methods, and I'll be leaning on some of you all who are more experienced in backnet for that to really kick off very well and really incorporate the classroom with the living lab so everything can be monitored. And opportunities for students to engage in real world problem solvings, I feel like we have those here because I can set up so many loopholes or so many barriers in a circuit, whether it be in the inputs or the outputs, and have students just troubleshoot. They can have troubleshooting lessons for days and days and days, and they would gather around and have discussions and probably work as a team and build those really good soft skills and team collaborative skills together. Yep. Can we do the next slide? All right. So I kind of touched on this, so I won't go too much into it. So these are just ideas for the future. Things such as integrating renewable energy sources like solar panels. We have some older solar panels, but we're going to have to integrate some new ones into our living lab experience. And let's see, expanding our sensory. So basically our sensors, I kind of explained what kind of sensors we have now, but things are being so innovative these days. They are sensors for all kind of things. So I just want to be able to integrate just be more diverse in our sensors. Let's see, integrating more sister programs. Yes, so I've been in talks with. I was talking about plumbing, for instance, integrating plumbing and commercial HVAC, a whole lot more. Make tickets for them to fix things like rooftop units and so on and so forth, and just being more collaborative efforts to and talks between the two classes. Use AI. That's just something that interests me. Using AI for a productive building to be more productive and accurate. That's just something that is interesting to me. Include practical outputs on the living lab. So, somebody asked me earlier about the outputs, and yeah, that basically just sums up what what we want to do in the future about the lights and adding a little bit of HVAC in there, if we could. All right. So on the right here, I just want to explain this picture here. This is just one of the diagrams, wiring diagrams that I have my students wire
Just
up.
to note, Justin, we're running a little bit short, so
Oh, okay. Yeah, no, that's about it. I'm being a little redundant. So that is about it. Do we have time for questions, Ted?
we'll move on to Trish, and people can ask questions as they come up, okay?
Sounds good.
Or
Thank you all.
for the end. All right, Trish.
Okay, so all right, so I actually our living wall, our living lab kind of started as what we call the living wall. And if you go to the next slide, please. What we wanted to do was to increase awareness for our building automation field, start to recruit some students to the program, but also building the community involvement and just kind of educating students in general. Our focus was, again, since this is a new program, just trying to get awareness out there. So if you go to the next slide, please. So in December of 2023, we did have a new certificate in building automation systems approved through our curriculum, along with the 7 courses. And so we wanted to begin offering that this past fall. Next slide, please. So the way our living lab kind of came about started back about a year before, where our students were going to have a student engagement project to build an automated living wall. And this is a picture of the first group of students. We can see we kind of designed the living wall. They did a lot of the design work, and then we had a system with the irrigation that was controlled by an Arduino. So this was kind of our first foray into the to controls part of the program. So the students really enjoyed doing this project. Not only did it give them some experience with the technical side, I also had some students who really didn't know that much about gardening or plants, and were very interested in just being able to participate in finding plants and so on for the project. So next screen, please. Well, on our campus, we actually had a greenhouse from a former horticulture program that had been basically abandoned. So what we did was decided to take this living wall and expand it. So if you could go to the next slide, please. So we actually purchased 2 farm bots, and I'm not sure if you're familiar with farm bots, but it is an automated gardening system, and it is all open source. So we just had to purchase the frame and the actual controllers for it. And then the students basically renovated the greenhouse and added the beds and built up the robots themselves. So we wanted to then kind of even take this a step further. The farm bots themselves can gather a lot of data, and we are able to program them to actually plant the seeds, keep the watering. They will monitor the weeds in the gardens, and then like I said, it will just gather data for whatever we program it to. So the students were able to install these farm bots, and they were able then to learn about just the controls. And then we expanded it to actually monitoring the conditions within the greenhouse. Now, like I said, this was a little bit of an abandoned greenhouse, so we haven't been able necessarily to correct all of the issues, but we were able to start monitoring the humidity in the greenhouse, the light, the amount of light that the plants receive, the amount of water. So we were starting to just introduce some basic building automation controls to the greenhouse. Any questions? I guess I could stop and see if there's any questions so far.
Nothing came up, although Jeff Polk did mention that the Living Lab project he had back at CMN years ago that actually Best Center visited, they have a video up online, and that's posted in the chat if anybody wants to go take a look at that. Go ahead, Trish.
Okay, so the next slide, please. So as you can see, we did start to install some controllers, basically maintaining growing conditions such as temperature, humidity, and light in the greenhouse. And we've been gathering data for the controls, from the controls, and also data from the farm bots. And we are hoping now eventually to get some additional equipment so we can really make this project a complete living lab. So next slide, please. But the big thing with this, we want to be able to identify any trends, look for ideal growing conditions, then look for energy saving opportunities for the greenhouse itself. And hopefully soon, as they were talking about earlier, we would like to incorporate some concepts of artificial intelligence into the application to control, you know, the different, I guess, trends as far as like when the plants are going to be the most productive, when do we have to harvest, and so on. Next slide. So we've had a lot of really positive outcomes with this. We did form a student organization on campus, so it was not limited to just building automation students. It has been, we've had students involved from many different disciplines, particularly like biology and some of our just non-general studies type students. So we have kind of expanded this. We've provided education, like I said, to a lot of our inner city students who really didn't know that much about farming or, you know, have any experience with farming. So it provided just some very basic education, not only for the farming, but also for robotics, some automation, and then how we can control the environment. So exactly what is the building automation system industry all about? As we were working on renovating the greenhouse, we also have a community garden on our campus, but it's an outdoor garden, and being in Pittsburgh, that's just a limited time frame that we can actually use it. But we had community members actually stop in the greenhouse, just trying to see what we were up to, and they got very excited about being able to expand the community garden to a year-round project so that they could also build, you know, keep their plants going and so on. So that actually kind of unintentionally excited a lot of the community. And then
That's what you want. You want to get them engaged and interested in and trying to get them into your programs as a result.
Yep, just to get it word out there, what it's all about. So, and then one of the positive outcomes too was we do have a campus cupboard. You know, a lot of our students have limited income, so we were able to provide fresh fruits and vegetables to or not fruits, but fresh vegetables to our campus cupboards, which they will weekly open up and give students food and supplies. So we were able to help support that project. We did normally do that with just the outdoor garden, but now we were able to provide that year round. So, and I think So I just put in the presentation, which is located, we have this document up on I'm not sure where it is, but it's connected to this. Welcome.
This tab.
This was where it started, this video, on how we actually designed the living wall. If you go to the next screen, I put in links to the supplies that we used, since this was kind of a hydroponic type garden for the living wall. We used that particular design, and just if you go to the next screen, this was the kits that we used with the Arduinos, and you can see there's little pumps there for the irrigation system. And then one more screen. That's the information about the farm bots. And like I said, that's all open source, so it was minimal cost involved in actually getting that material and then being able to incorporate that into our control system too.
So I don't see any more things come up in the chat, but does anybody have any experiences they had that they would like to talk about a little bit more? Otherwise, I can go into the ones that I've been involved with, or I can ask Jeff to expound upon his a little bit.
I've got a quick question for Trish. You're talking about pulling data out of both the contemporary controls and the farm bot. What protocols do you know that the farm bot talks?
The farm bot has the Raspberry Pis that will gather data, so we were able to pull that from their. Actually, it gets fed into there's a website that they that our robots communicate with, the farm bots communicate with, so we're able to pull the data from there.
Very cool. I love this project, soup to nuts. It's phenomenal. I do love it.
Thanks. I think it kind of was very unintentionally developed, but I think we've seen a lot of benefits from it. So
The thing that I like about your project, Trish, and it ties in with what Jeff Pope did down in New Mexico, is you have some repeatability capability with this. So you don't have to reinvent the wheel every year, so to speak. And you may not have been there yet, but it sounds like you're kind of going that direction. But I know, like with what I've done in the past, we've been doing basically one-off projects. Students would bring a project that they want, something they had interest in, where they worked, or their church, or an outside partner would come in, like local community group has a building that we wouldn't looked at, and we looked at a museum, and you can only go through those so many times, and they lose interest, or what you went there to help solve for them is done. So that repeatability helps in reducing your eventual workload. So
right. And I feel like it's just going to get better. So
yeah. Any other examples, or is Jeff still here?
Yeah, I'm
I
here.
have a quick question.
Go ahead, ask your question, and Jeff, if you want to explain yours after George is done.
All right. Yeah. So I'm very enticed by how you run those, and I'm at a larger university with large student cohorts. How big are the classrooms, or the cohorts of students you work with, and how do you deal with larger ones? So that is one in my question bank. The other one is, and then maybe more for Justin. You're interacting with a live building, and how are your facility operators okay with that? So
They're
there are any lessons for that, because this is a big issue for us.
Well, I think let's hit the number of students in a class. My student class has been anywhere from just several on up to about 12 or so. You start hitting that 10 to 12 students working on a project like that, it gets to be a little bit bulky. You got to break people up into groups. And so that for me, that's kind of where my limit was. I don't know, Trish, Justin, what's your experience?
Yeah, I've had to break ours into like two groups, so with our classroom sizes, and we kind of rotated. So and then they ended up actually helping each other with their different assignments. But we had about 12 people. We have about 12 people, so I broke it into 6 and 6 for now.
Yeah.
Hopefully we'll get more, but
Yeah, I broke mine into groups of 4 people, basically. 3 groups of 4 was kind of, I think, the highest one I had. Justin, how about you?
Yeah, I would say you don't want any higher than 4 people in a group, because there's always going to be somebody who's kind of just getting the easy A. Other than that, there seems to be something everybody can get their hands on. But I want to gear towards, because we're kind of limited, towards the other question. It was, how do we deal with facility maintenance? So basically, I was explaining that we are currently only doing inputs. So I would say that's a good place to start. I mean, that's kind of where you would start anyway if you would start to develop a building automation system in anywhere. Would be with inputs typically. So that way you could just monitor things first and then kind of ease them in to make them feel more satisfied that you're capable, that your students are cognizant to really get things done, I suppose. So kind of you want to trickle effect that. You don't want to give them the whole plan because they'll feel overwhelmed and they'll feel like they're not getting paid enough for it. Yeah.
All right.
As a quick response here, Ed, but I kind of envy you for the class sizes because we usually have to deal with a cohort of 40 that is a section for us.
Yeah.
And I'm with you, 4 would be the ideal size. We sometimes have to run with 5. So we need to constantly reinvent on how we can actually rotate students through an experience, and so they work at different items at different weeks. But I'm with you that the hands-on is just where they really get engaged, and then suddenly the light bulbs come up. So thanks for sharing.
Jeff, how many people did you have in your classes?
Back then, I'm not with CNM anymore. I left there in 2020, but for some perspective, at that time I was teaching HVAC basics for a credit associate's degree program at CNM, a faculty member, and we were having cohorts of anywhere from 15 to 20. But keep in mind, I had an agreement with maintenance facilities, and I said, look, we don't want to go manipulating things in your machines on our roof. What I want to do and what I did, and the video may show it that Carson put together back then, is we would take the whole cohort on the roof, and it was a group discussion, what we called a looky-loo. We would take panels open, show them where all the parts were that we were talking about and seeing in the books and in the lab. And it really sealed the deal with showing students who were relatively new to HVAC, oh, this is what these machines look like. There's where the filters are. There's where the blowers are. There's where the coils are. And so that's kind of how we implemented in the HVAC side, at the HVAC basic level. And maintenance was, facilities was fine with that as long as we weren't changing things on their machine, which, of course, it was a handshake deal on that part, but it worked out really well.
Good. Let's see here. Trish, Brian Tagg is going to want to connect up with you and talk to you some more about it. Justin, monitoring points that you have, has there been any measurable impact on energy use in the building? This is from Mike Conway.
Yes. So ever since we've attached CTs, current transducers, to the huge square ones around our energy management systems, we've been able to conserve, let's just say, upwards of 6 figures plus. So yeah, it was a huge turnaround and a huge eye opener for our students as to the possibilities that they can really fix, the problems they can really fix in the real world. So yes, it did make a huge difference. And this building is old, like old. So it needed those kind of upgrades anyway. Yeah. Oh, and matter of fact, that's a great question because that is another thing that we added on that actually does really impact. And yes, that is something that it shouldn't be that much of an issue as long as you have the right people attaching, know what they're doing, attaching that current transducer because that's nothing to play with. That's high voltage. So
That's where we come in as instructors to make sure they did those things correct or are doing
exactly.
and did it correctly.
Right. I probably want to have students attach
No.
their transducers.
So we're basically out of time and need to pass on to the other session here. But just one last thing. Thank you, Justin and Trish, for your time helping out with this and presenting good information. The slides are up there in the resources, and I think I'm gonna have, if Kim didn't already do it, have her put up the link that Jeff Polk provided us. If you have questions, everybody just reach out to us. With that, see everybody in the next session.
Excellent. Thank you. You have a good one.